Okay, in this lesson, we're going to be talking about expected value or expectation. The expected value of a probability distribution, which we talked about in the last lesson, is just asking you to find the mean of that probability distribution. So we covered this formula in the last lesson as well. We take x times p of x, and then we sum those products together. That value is called the mean, but it's also called the expected value of x. Okay, a lot of times these scenarios are gaming situations. So this first example says 1,000 tickets are sold at $1 each for a TV valued at $999. What is the expected value of the raffle if a person purchases one ticket? Okay, so I prefer to set mine up thinking about X representing the gain. So if I do that, thinking about how much I would gain if I win, I'm going to win the TV, which is valued at $999,000, but I had to pay $1 to play in the raffle. So really I'm only gaining $998 worth of a TV. And then if I don't win the TV, I'm gaining nothing. Okay. And actually I had to pay to play. So I'm in the hole, negative $1. Okay. Then if we think about the probability of those outcomes, winning the TV, I just bought one ticket out of 1,000 tickets sold. So my chance of winning is 1 out of 1,000. And then my chance of losing, there would be 999 losing tickets out of 1,000. In order to find the mean, we multiply these straight down and add. So 998 times 1 over 1,000, it's 998 over 1,000, plus negative 1 times 999 over 1,000, it's negative 999 over 1,000. And I would add those values up to get the expected value or the mean. And I get negative 1 over 1,000. We could write that as a decimal. So if we divide those two, negative 0.001, and that is in terms of money. So on average, each time that I play this game, I am losing money. I'm losing less than a cent, but I'm losing money. Okay. Another way that you can set this up is instead of setting it up in terms of gain, we could set it up in terms of the amount that I'm winning. This seems to be an easier setup for people. However, there is an extra step that we have to remember to do at the end. So I'm going to show you this as an option. I do prefer the first way that I set it up, according to gain. Okay, if we think about our winnings, if we win the TV, we win $999 worth of a TV. And then if we don't win, right, if we don't win the TV, we won nothing, 0. Probabilities would still be the same. So I have one chance out of 1,000 of winning that TV. So I have 999 chances out of 1,000 of winning nothing. I would still find the mean of this probability distribution by multiplying straight down. So I get 999 over 1,000 plus 0 out of 1,000. So I get 999 out of 1,000. However, if you set it up this way, you have to remember that you had to pay to play the game. So I'm going to subtract off the amount that I had to pay, which was $1. So 999 over 1,000 minus 1, that would still give me negative 1 over 1,000, or negative 0.001. So again, on average, I am losing money every single time that I play this raffle. That being said, whoever's hosting the raffle, every time that someone plays, the house, is expected to win money if we're losing money. Okay, this next question I just said, what is the expected value of the person who purchases 2 tickets? Now, you could set up a new probability distribution thinking about what could happen. However, since we know that this is the average winnings per play, we could just multiply that by 2. So if you've already calculated the expected value per play and you want to know the expected value for someone buying multiple tickets, just multiply the expected value per play times the number of tickets that they're buying. So on average, again, we would lose money. It's less than a cent that we would lose per play. But again, on average, we're losing money. Okay, the next example, we have a ski resort loses $70,000 per season when it does not snow very much and makes $250,000 profit when it snows a lot. The probability of having a good season snowing a lot is 40%. Find the expectation for the season. Okay, so if we think about what could happen for this ski resort, they could have a good season, meaning it snows. They could have a bad season, meaning that it didn't snow. Okay, if we think about their gain when it snows, it says they make $250,000 profit. Now, profit means that I don't have to subtract off anything. We've already paid the employees. We've, paid the bills. That's how much we're gaining. And the probability that it snows was given as 40%. Okay, the probability when it doesn't snow then is 60%, right? Those always have to add up to 1. And if it doesn't snow, they're going to lose $70,000. So negative 70,000 is what they're gaining. Okay, again, we could find the mean, so multiply down and add across. We also could enter these into our calculator. So I'm going to go over those steps. We press stat and enter. We put our X values in list 1, so 250,000 and negative 70,000. And we put our probabilities in list 2, so we have 0.4 and 0.6. We go to the same spot that we did before, so stat over to calc, 1 var stats, and we're telling the calculator that we're using both lists. Okay, our mean, remember we use the symbol mu, or expected value of X, is equal to $58,000. So on average, this company is gaining $58,000 per season. Okay, here's another raffle scenario. 1,000 tickets are sold at $1 each for 4 prizes of $100, $50, $25, and $10. What is the expected value if a person purchases 2 tickets? I'm going to set this up according to gain per ticket and then multiply by 2. Okay, so if we think about what could happen if I buy 1 ticket, I could win the $100 prize. However, I had to pay $1 to play, so I'd gain $99. I could win the $50 prize, gaining $49, the $25 prize, gaining $24, or the $10 prize, gaining $9. Don't forget, you could also lose, right? So we gain -1 if we do not win anything. Okay, probability of just buying 1 ticket first. We bought 1 ticket, so we have 1 chance out of 1,000 to win the first prize, or the second prize, or the third prize, or the fourth prize. We've used 4 chances, so now of losing is 996 out of 1,000, right? Those always have to add up to 1. Remember that rule for probability distributions. Okay, I'm going to find the expected value of X per ticket, but remember we're buying 2, so I'm going to multiply that by 2. I'm going to plug these in the calculator to make it a little easier to find that expected value or mean. So we have, oops, clear, enter to clear that list. Okay, so we have 99. We have 49, 24, 9, and -1 for x values. And in probabilities, we have 1 out of 1,000. I guess I could have put that in as a decimal, might have been quicker. For each of those, except for the last one, which is 996. Oops. Out of 1,000. Okay, we go to stats, over to calc, and again, 1-var stats, telling the calculator that we're using both lists, and we get a mean per ticket of -0.815. So if I multiply that by 2, I have on average, I am going to lose $1.63 for every 2 tickets that I buy. Okay, so in gaming scenarios, if we do have a negative expected value, that means that on average we are losing money. Therefore, the house is gaining money. A good thing to keep in mind, though, is if we get an expected value of 0, that means that the game is fair. Okay, so we are not expected to win or lose, and the house is not expected to win or lose. It kind of evens out. So we call that fair. Okay, so here's a question. Oops, here's a question that deals with that idea. 2 dice are rolled in a certain game of chance. If doubles are rolled, the player wins 10. If a sum of 3 or 11 is rolled, $5 is won. And if any other number is rolled, the player loses. How much should be charged to play the game if it is to be fair? Now, a couple ways you can set this up. I would actually recommend setting it up according to how much you win. And then remember that you have to subtract off the amount that you had to pay after you find that expected value of the win. That is going to be much easier than setting it up according to gain, because we don't know how much we're playing or how much we're paying to play. So it would be like the amount that we win minus X for each outcome up here. So it's going to be much easier to do the win. Okay, so we could win $10. We could win $5, or we could lose. So win nothing. Okay, it does tell us that if we roll doubles, we win 10. So that's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. So there's 6 chances out of those 36 possible outcomes when we roll 2 dice. A sum of 3 or 11. A sum of 3, we get a 1 and a 2, or a 2 and a 1. So there's 2 chances out of 36 to get a 3. Similarly, there's a 5 and a 6, or a 6 and a 5 to get a sum of 11. So that's 4 chances out of 36. We've used 10 chances, so that means there's 26 out of 36 left to lose. Okay, I would, again, find the expected value, find the mean of this probability distribution. I'm just going to multiply straight down and add, because these numbers are not that difficult. 10 times 636 would be 6036. 5 times 436 would be 2036. And 0 times anything is 0. So I get 8036 as my expected win. That as a decimal is, I'm expected to win $2.22. But remember, we had to pay to play the game. So we don't know how much we're paying. So I'm going to say that that's X, right? That was what we were trying to find. But we know that we want this game to be fair. Where is it? Right here. Okay. So fair means we get 0. Okay, so if we solve this, we would subtract the 222 from both sides, get negative X equals negative 222, or just X equals $2.22. So we see that that expected value, expected win, is what we need to charge in order for that game to be fair. Okay, the last example, we have the PTA is selling raffle tickets at the basketball game. The cost of the tickets are $1. 50 are sold. They are giving a prize of $10, 2 $5 prizes, and 3 $2 prizes. Find the expectation if you buy a ticket. I'm going to set this one up according to gain. So I could gain $9. Yeah, tickets are $1. So I would gain $9 if I won the $10 prize. I would gain $4 for the $5 prize, or $1 for the $2 prize. Or I don't have to win at all, and I would still pay $1 to play. So there's just one prize of $10, and if I bought one ticket, all right, I have one chance out of 50 tickets that were sold. But there are 2 $5 prizes. So I have a chance to win the first one and a chance to win the second one. So I have 2 chances out of the 50 if I just buy one ticket. There are 3 $2 prizes. Again, I have one chance to win any one of the 3 prizes. So I have 3 chances of winning the $1 prize. So I've used 6 chances. So there's 44 chances out of 50 that I would not win anything. We want to find the expectation for a ticket and then 5 tickets. Okay, so for just the single ticket, we would, again, multiply down and add across, or you could plug and chug in your calculator. I'm just going to go ahead and multiply down. So we have 9 50ths, 8 50ths, 3 50ths, and negative 44 50ths. Sorry, that's going to be scrunchy over there. Okay, so if we add those up, 9 plus 8 plus 3 minus 44, we have negative 24 50ths. If I find that as a decimal, so on average, we are going to lose 48 cents per ticket, per play. If I buy 5 tickets, again, I could just multiply that by 5. So on average, I'm losing $2.40 for every 5 tickets that I buy. Okay, we are interpreting the meaning of these. So on average, I'm going to lose 48 cents per ticket per play. And on average, I'm going to lose negative $2.40 for every 5 tickets that I buy. Okay, this concludes the lesson on expected value or expectation.